Welcome everyone, and welcome to the third day of PyData Global. And I hope that last 2 days were amazing. So we are today joined by Irina, and Irina would be speaking on the prototype whole and tools to help you out of it. So Irina, over to you, and could you please start with a short bio of yourself? That would be wonderful.
Okay, yeah, actually, it's very soon in the slides. So just first, thank you all for joining today. In fact, what I'm going to be presenting today is really a continuation of chats that have been going on in PyData over the last couple of days. I've seen this come up in talks already. So it seems to be happening it doesn't seem, I know that it's been happening in different places. What triggered this, or the excuse to talk about this, if you will, was an article that came up talking about how they called it AI tools. They were covering data science, data-driven machine learning tools, and how they had translated to tools that helped with COVID or that, well, didn't. I've also seen another paper that looked at other papers that had been published over, during the year, during a year of collecting data and trying to come up with models for diagnostics, for prognosis, and how what the authors found was that all of them had severe methodological flaws, and none of them really qualified to go up to products that could help in a clinical setting. Now, I care about this, and this is where I can tell you a bit about myself, because, well, I've got a past in medtech, and then I've spent several years around computer vision, machine learning products in startups, and now in the mobility sector. By the way, the opinions here are my own. I'm not here representing my employer. So this is all opinions about what I've seen in different sectors over the years. What I'm assuming about you is that you also care about this, that you've been involved in machine learning, data-driven, computer vision, all that domain, prototypes, potentially products, and that you would like to increase that ratio of product to prototype that we have. Now, the first thing I wanted to do was ask, okay, if we have that situation, which in truth we do, why is that? And to be fair, by the way, there are many applications that have helped in COVID and help us every day. So we know that, I don't know, in logistics, there's plenty, there has been plenty going on. There's a lot of tools, of data-driven tools that have been helping. However, in the clinical setting, not so much. So why was that? And you'll see how this relates to other sectors as well. Now, the first thing that they identified was that they were working in less than ideal settings. Then I thought, okay, is this only in academia? It's definitely unfair to say it's just academia. So, okay, where do practitioners go when they're first exploring? Maybe Kaggle. You go to Kaggle and then you suddenly see that there's 3,800 data sets. And bear in mind, this is data collected over a year. Almost 4,000 data sets is bonkers. So there might be something in there too. But let's keep asking why. So why do we have this situation? And through Rachel Thomas from FastAI, I reached the COVID tracking project, and they have published several articles covering their problems collecting data and processing it, and how they had a huge disconnect between the people who were publishing that data, the metrics they were using, what the data they were publishing meant, which rendered any pipelines they could have set completely useless. Now, so again, why do we have this situation? Well, luckily, several articles have covered recommendations to both practitioners in the industry and in academia about how to proceed. So then the factors that kept coming up again and again were that disconnect between domain experts and what we'll call AI people. And I'm saying AI very loosely, as usual, covering data science, machine learning, a bit of data-driven tools, basically. So there's this disconnect between the domain and the data people. They're not talking to each other. They're not using the same terminology. They don't know the same things. There was also a problem about data heterogeneity. So basically a mess, no standardization. There's also a problem in reproducibility. So there's, again, a disconnect between, and this time between data people and other data people, because if others cannot reproduce what you're doing, they also cannot jump in and help you. So what can we do about this? And how does this, and of course, this relates to other sectors. This is not just academia, and it's definitely not just in clinical science. This is happening everywhere. We see it in any sector we've worked in. So what can we use to make it easier? Now I'm going to approach this through the machine learning cycle. So you've seen variations of this in plenty of places. And I would start, and this obviously starts with understanding what's going on. And there are several other steps that we all need to go through. And I'm going to emphasize the human factor. So again, remember the problems that we were seeing, and I'm going to show them again, where this disconnect between humans in different steps of the problem. So which rendered which meant that we were losing domain knowledge, and it made our data useless, and it even made our code almost useless, right? So in each of these steps where you're understanding the business, you need to be communicating efficiently with humans. When you're sourcing your data, when you're labeling, when you're versioning so that others know what you're using, you need to be keeping in mind other humans. Let's assume model creation is a bit of a silo, shouldn't, but is, but okay. But in deployment, you're also thinking about how people are going to be consuming the predictions that you make. So you need to be thinking about humans. Last of all, monitoring, because no model can stay the same forever. It would completely fail. And typically this makes you have to go through the merry-go-round again. Now, let's keep in mind these three problems, right? Especially the disconnect between domain and data people, and the problem in reproducibility. So starting with the business understanding, what tools can we use to make things more efficient there? And the first one I'm going to give you isn't even code. It's the only one that isn't code, but it's a really good one. And this one I found out about at a meetup where Louis was presenting the tool. And it's basically about asking the right questions and being systematic about it. So before I knew about his machine learning canvas, I had a checklist where you typically have to go through someone either from your employer, your customer, your user. You sit down with them and you start asking things about what exactly is their problem? How do they want you to solve it? What data do they have? Where is this going to be running? And what kind of UI are they expecting? Where does this fit in their decision process? So a lot of questions that really matter, so that you're not just in your corner doing fun stuff, but the output can really have an impact in what people are doing in their business. So the good thing about either having a checklist, choose this canvas, choose whatever you want, but the importance is that you don't skip steps, that you make sure that you cover all of these topics. Now, that doesn't stop there, because humans have a really hard time describing what they want. Usually they know when they see it, but not always. But at least what you can do is prepare a really quick prototype end-to-end, so a toy version of what it's going to be end-to-end, to at least let them tell you if you're completely off the mark, and to avoid what you could call the magical box syndrome. Like, okay, so I've got this problem, let's AI solve it. Okay, but how specifically? What kind of predictions do you need? What are you going to put in and get out? And this is where I'm going to be talking about a couple of really nice tools. So I personally, because I don't work that much with dashboards, I really like Gradio, which what it does is gives you a UI that you can stick on top of, say, a Jupyter notebook, or anything else really. So if you've got your Python code, you need to prepare a quick user interface, and you stick this on top, and it gives you a nice way of communicating already with your user. If you, on the other hand, use dashboards, I should point you to a workshop that happened 2 days ago, so Thursday, the Dashboard Showdown, where tools like the one I know best is Streamlit, but there's other classical ones like Dash and others that that are being described here. So I would point you in that direction. But the point of all this is get a user interface of some sort to your user as early as possible so that they can tell you what they want. Now let's talk about data and how that still relates to the human factor. Now, the only way to extract domain knowledge from your users, from your domain experts, and put it into your models is through the data. That's the whole point of data-driven applications, right? So how can they give you that? Through labeling. Now, when you sit with them, that's when you suddenly realize that there are no labels. And then comes the sequel of that magical black box syndrome. But there's this thing called unsupervised. You solve it with unsupervised learning. That's a hard conversation. There's plenty of literature that can compare results of unsupervised versus supervised methods. But what you can do after you have that conversation is sit down with them and discuss about labeling. And you want to make it easy for them. So there's tools that can help you. For instance, if you're it's going to be very modality dependent, right? So if you're working with images, one I really like is CVAT. It's Fermental, but it's open source, because you can already stick a pre-trained method behind it, let it do predictions and have your users correct them. But there's others that can help them just sit down and go sample by sample and annotate. Now that's a bit too much. So I really like another approach like Human Learn, which is, it kind of relates to CVAT, but for text. Where and here shout out to Vincent Warmadam, and be sure to check his talk in PyData Amsterdam, where the whole idea is maybe you can find clusters of data, represent them, plot those representations, plot those embeddings, and have your user just kind of draw to tell you what they find in common in them. And that's a way of translating what's in their head, which is extremely valuable, because that's where the devil is in the details, and not all data is the same. Not all sectors are the same. So that's a way of translating that into your data so that you can make your models better. And again, I'm going to bring up Gradio, and I swear I'm not affiliated to them. But if you need something else, then you're going to have to prepare an annotation tool pretty quickly. So that's where a tool like this can come in. And I particularly like it because there's this nifty flag button, which means that if you're showing, say, predictions from a model that you've already pre-trained, and they see something that doesn't ring true, they can just click on it and say, this was a bad prediction. And that's an annotation you can add very easily. Last thing about this, please version your data and help your colleagues help you. I'm not going to stop in model creation, mostly because it takes about 90% of the time we talk about these things, but it's like 5% of the total work. All I'm going to say is there's plenty of tools to track your experiments. Please find one that you like and use it. But let's now talk about deployment. So assume that you already have your model, and you need to start thinking again about how your user is going to be consuming the data and where. And that's where, and hopefully you've thought about this already in the initial step, but perhaps you forgot, and then you need to ask them, are you going to be using this, say, in your phone? Or are you going to be using it somewhere else? And if it's on a device, does maybe they're sitting in an office where there's no connectivity, or maybe they're in a workshop, or maybe they are somewhere where there's simply no data connection, maybe because of privacy reasons. And then you realize that all the processing, because of how they work, their workflow, you're going to be constrained to deploy your models on a device with no connectivity, and it has to be running on device. So after crying, there are tools that you can use. Typical ones are, well, TensorFlow Lite, and that's been there for years. If you're targeting a very specific hardware, like if you're going to be using ARM devices or Intel devices, they all have their own specific libraries. So take a look. bear in mind that what you will be able to deploy, and bear in mind, especially if you're doing deep learning, if you're using neural networks, bear in mind that not all of the layers that these libraries support are so bear in mind that not everything that you can train with TensorFlow, with PyTorch, will be available to you in these. So they typically have a lag, and they don't always implement everything in those frameworks. And in any case, always use a light model. Now, if you're not constrained in that way, if you don't have to worry about TinyML and processing on a device, then you have a ton of more options. There's tools like MLflow and BentoML that can help you ship or package and serve behind an API. So models trained with many different libraries. I tend to prefer MLflow because I'm lazy. So if I'm already tracking my experiments with MLflow, then I can just package it and serve it. But there's other options available to you. And also, I'm sure I've seen here the other day in PyData Global a talk about TorchServe. So I would encourage you to look it up if you're interested in it. Now, if you prefer being a bit more in control of what you're doing and you want to define it, you can also write your own API. So there's tools like Fast API to help you do it a bit better. And of course, Flask has been there really long. So if you prefer that, go for it. One last comment: if you don't really know what platform you're going to be, it's strange that you don't know where you're going to be deploying. But if you want to remain a bit generic, think of exporting your models in the Onyx format. Hopefully one day all deep learning frameworks support a standardized method, a standardized packaging, and it could be Onyx, so that we don't have to worry about converting from one to the other. So this is the closest we've come. Last step of all, monitoring. So you've managed to train something that you're happy with. You know that it does what your users were expecting. You've actually deployed it. And then, well, of course, that's just the start of the journey, right? Because the moment you deploy it, you realize that your real data in production has nothing to do with what you had trained on. And so you need to retrain again and again. And I'm really hoping for your own sake that you had that automated. Otherwise, well, get started and automate your training pipelines. Now, for that monitoring of metrics, and you typically want to be monitoring things like latency, things like uptime, but for machine learning models, you're going to want to be keeping track of how it fares in incoming data as opposed to old data. So maybe you will have to have a lag while you're annotating production data, because that's the whole point. You didn't have labels for it. So there's going to be a lag, but make sure that you are tracking performance, whatever your metric is, on the real data. So when that performance deviates from what you expect, an alarm can be triggered. So you can be storing it with Prometheus. You're keeping an eye on it with Grafana, and there's libraries that you can use to set up alarms, so that the retraining can be triggered. And I'm going to stop here so that to take your questions. We've been looking at quite a few very quickly, but we've been looking at all of the steps in a typical machine learning cycle, and tools, even if they're not code, but most of them were code, to make that collaboration with humans a bit easier, so that we can match that knowledge about the business with the knowledge about data that makes a prototype go to the product level. But the whole point of this is, it's not really about the tools. So if you remember this diagram about the swing and the misunderstandings, look at the date. It's almost half a century old. So we were dealing with that half a century ago, and we're still here now. So these challenges are going to stay there. So whenever you're seeing this, maybe the tools I've been talking to you about are not there, but make sure you look at how to improve these 3 problems and make sure that you find the tools in your time that help you bring domain experts and data experts together, understand the problem. I'm going to stop now. You can find me, well, on GatherTown in a few minutes, or on LinkedIn or on Twitter, but I'm happy to take your questions now. Thank you very much.
Thank you, Irina, for the presentation. Let's see if we have questions for you. All right, we have a question for you. The question is, although I understand it is not really about the tools, how much effect does saving format of a model have?
Well, it does quite a bit, because if for some reason you need to change your libraries at the middle of the project, if you had been storing it in a format that had nothing to do with the target platform, then you need to go back to square one. So for instance, and that also happens when you start collaborating with other people, and there's the I'm PyTorch, you're TensorFlow, or now there's PyTorch Mobile, but not so long ago, PyTorch Mobile wasn't there. So if you were saving, say, thinking that you were going to be, so you didn't think that you were going to be deploying on an Android phone, and you were training on PyTorch, and suddenly you need to use TensorFlow Lite, you started having to, you had problems converting. You had to look for converters or write your own. And so anytime you have to deal with edge devices or edge deployment, formatting does matter. Yeah, quite a bit.
All right. How does one introduce this in the culture of a company, and how easy is it?
So there's different things you can do. So it's easy or not depending on how much sharing culture there can be. You can introduce it simply by exposing people to these practices. So it's when people say data science is a silo, it's not that by nature it has to be a silo. It's simply that people are used to working that way. So they were working that way when they were in their studies. They were like that in grad school. So they continued because they thought that's the way you work. If they realize that there's another way of working, they see the benefits and they adopt it. So it doesn't have to be hard. So ways of doing that is through these talks, so meetups, conferences, hackathons, getting out there and mixing with other people that have other ways of working. So I think that's how you can introduce that into companies. That's a nice way.
I think I agree on this. So Robert says, great talk, thank you. And Tom has a remark for you. Sometimes there's also purposeful obfuscation on part of domain experts, unwilling to relinquish their position in the chain. What do you want to say on this?
So I definitely haven't talked about other human problems like relationships and how you collaborate with others, because it really isn't about the libraries. It's about how you convince someone who has a really different mindset and maybe it's in a really conservative industry that what you're doing is actually going to help them. That's a really long process of building trust. So yeah, that can happen, but I guess you need to play the long-term game and slowly build that trust with them and convince them that it's really for their benefit.
Seems like we don't have any more questions as of now. So Irina, I would like to thank you very much for coming for the presentation, and it was a pleasure having you.
Thank you very much for having me.